Now, in a single slit diffraction experiment, the width of the slit is made double the original width. How does this affect the size and intensity of the central diffraction band? So here answer is, if we made it double, the size of central diffraction band reduces to half and intensity will be increased up to 4 times. Then second question, in what way is diffraction from each slit related to the interference pattern in a double slit experiment? So interference pattern in double slit experiment is modulated by diffraction from each slit. The pattern is the result of the interference of the diffracted wave from each slit. Then third question, when a tiny circular obstacle is placed in the path of light from distant source, a bright spot is seen at the center of the shadow of the obstacle. Explain why. So third question, when tiny circular obstacle is placed in the path of light from a distant source, a bright spot is seen at the center of shadow. This is because light waves are diffracted from the edge of the circular obstacle. So light waves are diffracted from the edge of a circular obstacle, which interferes constructively at the center of shadow. This constructive interference produces a bright spot. Then fourth is, two students are separated by 7-meter partition wall in a room 10-meter high. If both light and sound waves can bend around obstacle, how is this that the students are unable to see each other even though they can converse easily? So here, bending of waves obstacle by large angle is possible when the size of the obstacle is comparable to the wavelength of the waves. So here, on the one hand, wavelength of light waves is too small, is comparison of the size of obstacle. Thus diffraction angle will be very small and students are unable to see each other. On the other hand, size of wall is comparable to the wavelength of the sound waves. Thus the bending of the waves takes place at a large angle, hence the students are unable to see each other. So here, first of all, that wavelength is too small, and also that bending at a large angle. So these are the two factors. And then ray optics is based on the assumption that light travels in a straight line. Diffraction effects observed when light propagates through small aperture slits or around small obstacle disprove this assumption. Yet the ray optics assumed is so commonly used is understanding location and several other properties of images in optical instruments. What is the justification? So here, this justification is that in ordinary optical instrument, the size of the aperture involved is much larger than the wavelength of the light used.